So, okay, let's have a look at the cos graph, then let's take a break, okay? So, right, to think about the cos graph, we're just now going to look at the x-coordinate instead of the y. So when we came up with the sine coordinate, we were looking at the y-coordinate at each point, okay? Now to find the cos, we need to look at the x-coordinate, okay? So, let's have a think. What's the range of cos? And -1 again. Yeah, can you see why? Can you see why? Because again, so sine we were looking at the height. We were looking at the height. Now for cos we're looking at the width, the length across, okay? So in other words, the maximum we can move across is 1 and the minimum we can move across is -1. So again, it's got to be bounded between 1 and -1. Is that okay? Right, so let's have a think. What would the cos of 0 be? Good, because we're going to be looking down here when theta equals 0 degrees. Therefore, the cos of 0 is going to be equal to 1. The cos of 0 is going to be equal to 1. Okay. What would the cos of 90 degrees be? Good, because we're back up here now. So the cos of 90 degrees is going to be equal to 0. So we're down at 0. Okay. What would the cos of 180 degrees be? Good, because this is 180 degrees. So the cos of 180 degrees is going to be equal to -1. Okay, what about the cos of 270? 0, good. So 0 again. And what about the cos of 360? Back to 1 again. Okay, so back at 1 for 360. Okay, so again, I'm going to join them together with a curved line. So here we go. So we get something like that, and then this, and then this, and then this. Okay, so that would be the cos graph. Okay, so blue graph would be the sine graph. Red graph would be the cos graph. Okay. Now you notice they look very similar to each other, don't they? They're kind of this same sort of sinusoidal shape, okay, the same kind of curved shape. But can you notice some differences?
The reverse.
Reverse. What do you mean by reversed?
Reverse with whenever the other graph goes up, the graph goes down.
Okay, good idea, good idea, okay. So whenever one graph is going up, this graph is going down, okay. But we look at this graph is going down and this graph is also going down. I think a better way of saying what you're doing, is this graph is just off by 90 degrees. Do you see that? Yeah, this graph is off by 90 degrees. So in other words, this graph is 90 degrees ahead of where this graph is at. So this graph starts down here at 0, whereas this graph starts down here at 1, okay? Well, this graph doesn't get to 1 until 90 degrees, but this graph is already back at 0 again. Then when this graph gets to 0, this graph is down here at -1. Then by the time this graph gets down here to -1, this graph is back at 0 again. Then by the time this graph gets back to 0, this graph is ahead of it, it's back at 1, okay? So in other words, this graph is ahead by 90 degrees. It's ahead by 90 degrees. Now, if you think about it, that shouldn't be a surprise. That shouldn't be a surprise. Because have a think about your right-angled triangle again. Okay? So, if this is the angle I'm interested in, let's say this is theta, right? This would be your adjacent. This would be your opposite. And this would be your hypotenuse. Okay? So in other words, the sine of theta degrees is equal to this side over this side. Okay, so let's call it like x, y, and z. Okay, so this graph would just be x over z. Okay, but then if I look at it in relation to the other angle, for example, this angle up here, okay, what would this angle be? So if I know this angle, say if it was 20 degrees, what would this angle be?
70.
Good. So in other words, these two angles have to add up to 90 degrees. So therefore, if this is theta, this has got to be 90 minus theta. You happy? Happy with that? This was 20 degrees. 90 minus 20, that's my 70 degrees. Okay. So now, if I do it in relation to this angle, okay, remember I was comparing this side and this side, I'd now have to be comparing the cosine. Yeah? So I'm saying this is just simply this side and this side is the ratio of the cosine of 90 minus theta. 90 minus theta. So can you see that literally cosine is short for complement of sine? In other words, these two angles have to add up to 90 degrees together. Yeah? So cosine literally means complement of sine. Hence why this graph is 90 degrees further ahead. Okay? Because they're off by a factor of 90 degrees. They're off by 90 degrees, a shift of 90. Okay? So if you're ever not sure, just think these two graphs are exactly the same as each other. It's just this graph is ahead by 90 degrees. Ahead by 90 degrees, okay, in relation to this graph down here, okay? And the reason for that is if you think about transformations of graphs, this would simply be, I guess another way of writing this would be that sine of theta is equal to, no, let me think about that actually. But effectively you can think about your transformations of graphs and you can see that that is just a shift of 90 degrees. It's a shift of 90 degrees. Hence that's 90 degrees to the right of this one. Okay, sorry, to the left of this one. Okay, so what I want to say about this, you've got a sine graph and you've got the cos graph. I will just now expect you to draw these two graphs. Okay, so I need to give you some skills which you can use to be able to draw them like that. So you don't have to go through this process all the time. First of all, notice the shape. The shape is the same in both of them. This one is just ahead by 90 degrees. So that's one way that you can remember how the two graphs are drawn. Another thing which you can think of is every 90 degrees, something interesting happens. Now what I mean by interesting is either it reaches a peak, so in other words here, or here, or here, okay? Or it reached a trough, in other words the minimum point on the graph, so here or here for example, okay? Or it cuts through the axis, so x-intercept. And one of these three things will happen every 90 degrees. So have a look, work this through with me. So we start at 0, and we start off at 0 degrees, it goes through the axis, it's an x-intercept, okay? 90 degrees later, it reaches a peak. 90 degrees after that, it goes through the axis. 90 degrees after that, it reaches the trough. 90 degrees after that, it goes through the axis, okay? So if you're not sure, you've got the shape, but you're not sure where you should mark these angles, just think, every 90 degrees, something interesting happens. Either peak, trough, or it reaches an x-intercept, okay? And then you just have to work out, well, how do you draw these two graphs? Well, you just remember, sine starts at 0 and cos starts at 1 because it comes from this idea, okay? So you can relate it back to this unit circle if you're not sure. You just think you always start at this point, and this point is 1, 0, where the x-coordinate is your cos and your y-coordinate is your sine, okay? Or you can just remember, sine starts at 0, cos starts at 1. All good?